The Japanese naval intelligence officer stood in stunned silence aboard the damaged American carrier. It was October 7, 1944, and Lieutenant Commander Toshikazu Ohmae had just been granted access to examine USS Franklin, an Essex-class carrier that had limped into Ulithi Atoll after taking bomb damage off Formosa. Through a bizarre series of circumstances involving neutral observers and intelligence-sharing protocols that would soon be abandoned, Ohmae found himself walking the hangar deck of America's most modern carrier design. What he discovered in his 3-hour inspection would shatter every assumption Japanese naval planning had built upon. The Franklin was the 5th Essex-class carrier commissioned. Her nameplate showed a commissioning date of January 31, 1944. Ohmae pulled out his notebook and began comparing this date against Japanese intelligence files he had memorized. USS Essex herself had commissioned December 31, 1942. Yorktown followed in April 1943, Intrepid in August. The pattern was impossible. America was launching these massive warships every 6 to 8 weeks. His hand trembled slightly as he calculated the implications. If the Americans maintained this pace, and intelligence suggested they were accelerating, the Imperial Japanese Navy faced not a fleet of rivals, but an unstoppable tide of industrial production that rendered traditional naval strategy obsolete. The central question that would haunt Japanese naval command for the remainder of the war had just crystallized in Ohmae's mind as he stood on Franklin's deck. How does a nation fight an enemy who can build capital ships faster than you can sink them? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Japanese Navy's confidence in 1941 had been absolute and well-founded. For nearly 4 decades, since Admiral Togo's stunning victory over the Russian fleet at Tsushima in 1905, the Imperial Japanese Navy had cultivated a reputation for excellence that few naval forces could match. Their officers spent years in rigorous training programs that emphasized tactical innovation, night combat proficiency, and the perfection of visual gunnery techniques that had proven decisive in engagement after engagement. By December 1941, when war erupted across the Pacific, Japan possessed 10 aircraft carriers of various classes. The Kaga and Akagi, converted from battleship and battlecruiser hulls, displaced over 40,000 tons each and carried over 90 aircraft. The Soryu and Hiryu represented purpose-built fleet carriers of advanced design. The Shokaku and Zuikaku, commissioned in 1941, were the finest carriers Japan had ever produced, incorporating lessons from years of operational experience and capable of embarking over 80 aircraft in modern, well-protected hulls. These were not paper ships or hasty conversions. They were the product of 2 decades of continuous carrier aviation development. Japanese naval aviation had pioneered techniques for coordinated strike operations, perfected the art of torpedo bombing against maneuvering targets, and developed the doctrine of massed carrier task forces that would dominate Pacific naval warfare. The pilots who flew from these carriers in December 1941 were among the most experienced naval aviators in the world, veterans of combat operations in China who had honed their skills against real opposition. The Japanese Zero fighter had proven itself superior to every opponent it had encountered, with exceptional range, maneuverability that allowed it to outturn any contemporary fighter, and armament adequate for destroying bombers or engaging in dogfights. The Zero gave Japanese carriers an offensive punch no other navy could match. Japanese torpedo bombers carried the Type 91 aerial torpedo, a weapon that combined reliability with devastating explosive power. Japanese dive bombers had demonstrated pinpoint accuracy in combat operations. When Admiral Chuichi Nagumo's 6 carriers struck Pearl Harbor on December 7, 1941, they demonstrated operational capability that shocked American observers. The coordination of the strike, with over 350 aircraft arriving over their targets in carefully orchestrated waves, represented the culmination of Japanese carrier doctrine. The devastation inflicted, 8 battleships damaged or sunk, hundreds of aircraft destroyed on the ground, validated decades of Japanese naval aviation development. American carrier strength at the outbreak of war stood at 7 fleet carriers. 3 were in the Pacific: Enterprise, Lexington, and Saratoga. 4 were in the Atlantic: Ranger, Yorktown, Wasp, and Hornet. By displacement and aircraft capacity, American carriers were comparable to Japanese equivalents. The Lexington and Saratoga, converted from battlecruiser hulls like their Japanese counterparts Kaga and Akagi, displaced over 40,000 tons. The Yorktown-class carriers were purpose-built fleet carriers capable of embarking over 80 aircraft, but Japanese intelligence officers, examining American carrier strength in early 1942, noted factors that suggested American vulnerability. American naval aviation doctrine was less developed than Japanese equivalents. American pilots had less combat experience. American torpedoes, as would become painfully apparent, suffered from catastrophic reliability problems that would plague submarine and aviation operations for the first 2 years of war. American carrier operations lacked the coordination and tactical sophistication Japanese forces had demonstrated at Pearl Harbor and would demonstrate again in subsequent operations. The Battle of the Coral Sea, in May 1942, seemed to validate Japanese confidence. The engagement was tactically inconclusive, with both sides losing one carrier. The Americans lost Lexington, a 43,000-ton fleet carrier representing significant combat power. The Japanese lost Shoho, a smaller carrier converted from a submarine tender. More importantly, the fleet carrier Shokaku suffered damage, requiring months of repair, and Zuikaku lost so many aircraft that she required extensive time to reconstitute her air group. But the engagement suggested that in carrier versus carrier combat, neither side possessed decisive advantages. Midway in June 1942 shattered Japanese assumptions about carrier warfare in the Pacific. The battle demonstrated that American intelligence capabilities, American damage control, and American industrial capacity were creating advantages Japanese planning had not accounted for. 4 Japanese fleet carriers, Kaga, Akagi, Soryu, and Hiryu, were sunk in a single day. These were not marginal units, but the core of Japanese carrier striking power, the ships whose aircraft had devastated Pearl Harbor 6 months earlier. The loss was catastrophic, but Japanese Naval Command initially believed it was recoverable. 4 carriers sunk represented severe damage to Japanese naval aviation, but Japan still possessed 6 fleet carriers, including the modern Shokaku and Zuikaku. More carriers were under construction. The Taiho, Japan's most advanced carrier design, was being built incorporating armor protection and improved damage control features learned from early war experience. The Shinano, originally laid down as a Yamato-class battleship, was being converted to carrier configuration and would become the largest carrier ever built at over 70,000 tons displacement. What Japanese planning failed to account for was the exponential nature of American industrial mobilization. The United States was not simply replacing losses, it was building an en-place, entirely new fleet on a scale that Japanese intelligence officers, even when they possessed accurate numbers, struggled to believe was physically possible. The Essex-class carrier program had been authorized before American entry into the war. The first ship, USS Essex, had her keel laid at Newport News Shipbuilding on April 28, 1941. This was 7 months before Pearl Harbor, evidence that American naval planning had anticipated conflict regardless of diplomatic efforts to maintain peace. The design represented accumulated American carrier experience translated into a purpose-built warship, optimized for Pacific operations. The Essex-class standard displacement was 27,100 tons. Full load displacement reached 33,900 tons, making these carriers slightly smaller than the Lexington-class converted battlecruisers, but significantly larger than the Yorktown-class carriers that had fought at Coral Sea and Midway. Length overall measured 872 feet. Beam at the waterline was 93 feet, extending to 147 feet 6 inches at flight deck level. These dimensions translated into operational capability that Japanese carriers could not match. The flight deck provided sufficient space for sustained operations, launching and recovering aircraft at rates that maximized sortie generation. Hangar deck height of 17 feet, 6 inches, accommodated larger aircraft with folded wings, allowing greater aircraft capacity than Japanese carriers of comparable displacement. 4 elevators, 3 centerline and 1 deck edge, moved aircraft between hangar and flight deck faster than the 2 elevator arrangements Japanese carriers typically employed. The propulsion plant generated 150,000 shaft horsepower through 8 Babcock and Wilcox boilers, feeding 4 Westinghouse-geared turbines. This drove 4 propeller shafts at speeds exceeding 33 knots, making Essex-class carriers among the fastest capital ships afloat. Fuel capacity of 6,380 tons gave these carriers operational range of 20,000 nautical miles at 15 knots, sufficient for extended operations across the vast distances of the Pacific without constant replenishment. But the numbers that truly mattered were production numbers. USS Essex commissioned December 31, 1942. Yorktown, the second ship of the class named for the carrier sunk at Midway, commissioned April 15, 1943. Intrepid followed on August 16, 1943. Hornet, named for another carrier lost earlier in the war, commissioned November 29, 1943. By the end of 1943, 4 Essex-class carriers were in commission. The pace accelerated in 1944. Franklin commissioned January 31st. Ticonderoga followed on May 8th. Randolph on October 9th. Lexington, replacing the carrier lost at Coral Sea, had actually commissioned earlier on February 17, 1943, making her the second Essex-class carrier in service. Bunker Hill commissioned May 24, 1943. Wasp, replacing another lost carrier, commissioned November 24, 1943. By mid-1944, when Lieutenant Commander Ohmae stood on Franklin's deck calculating the implications, 8 Essex-class carriers were operational in the Pacific. Hancock would commission April 15, 1944. Bennington followed on August 6, 1944. Boxer commissioned April 16, 1945, too late for extensive combat operations, but demonstrating that production continued even as victory approached. The final count was staggering. 17 Essex-class carriers commissioned between December 1942 and April 1945. This represented an average production rate of 1 fleet carrier every 9 weeks across 28 months of sustained construction. At peak production, American shipyards were launching Essex-class carriers at intervals of 6 to 8 weeks. This was not theoretically possible, according to Japanese shipbuilding experience. Fleet carriers required years to construct, not months. The explanation lay in American industrial organization applied to warship construction with systematic thoroughness that Japanese industry could not replicate. American shipbuilding had learned mass production techniques from automotive manufacturing and adapted them to naval construction with remarkable success. The key was standardization combined with distributed production of components manufactured to precise tolerances that allowed final assembly to proceed at unprecedented rates. Newport News Shipbuilding constructed 9 Essex-class carriers. Bethlehem Steel's Fall River Shipyard in Quincy, Massachusetts built 3. Philadelphia Naval Shipyard built 4. Brooklyn Navy Yard built 1. Norfolk Navy Yard built 2. New York Naval Shipyard built 3. The distribution of construction across multiple yards meant delays at one yard did not halt the program. Competition between yards drove efficiency improvements that spread across all construction sites. Each shipyard employed tens of thousands of workers operating around the clock in shifts that kept construction proceeding 24 hours daily. Newport News Shipbuilding at peak employment had over 31,000 workers. Bethlehem's Fall River Yard employed 20,000. Philadelphia Naval Shipyard's workforce exceeded 25,000. These were not traditional craftsmen but industrial workers trained in specific repetitive tasks that could be performed to specification without requiring years of apprenticeship. Women comprised significant percentages of shipyard workforces. By 1943, women represented approximately 10% of shipyard workers in major naval construction yards, a proportion that increased to nearly 15% by 1944. These women operated cranes, wielded welding torches, installed electrical systems, and performed thousands of specialized tasks that traditional naval construction had reserved for male workers. The famous Wendy the Welder Propaganda images represented real women whose labor made the Essex-class production schedule possible. The construction process began with keel laying, a ceremonial event that marked the start of formal hull construction. The keel, the structural backbone running the length of the ship, was laid in sections that had been prefabricated in separate workshops. These sections were lifted by massive overhead cranes and lowered into position on the building ways, where they were welded together with precision that would have seemed impossible to naval architects of the previous generation. Prefabrication represented the fundamental innovation that made rapid construction possible. Rather than building ships sequentially from keel up with each component installed only after previous work was completed, American shipyards manufactured major components simultaneously in separate workshops. Hull sections were assembled complete with internal framing. Bulkheads were built with cable runs and piping already installed. Deck sections were manufactured with supporting structure in place. These components arrived at the building ways ready for installation, dramatically reducing time required for final assembly. Electric welding had replaced riveting as the primary method of joining steel plates. This single technological change accelerated construction dramatically. Riveting required teams of workers with specialized skills, heating rivets, positioning them, and hammering them into place. The process was slow, labor-intensive, and produced joints that were heavier than necessary. Electric welding allowed single workers to join steel plates faster and with lighter joints that saved weight while maintaining strength. By 1943, over 90% of hull assembly used welding rather than riveting. The Essex-class design had been optimized for production from the beginning. Naval architects understood that wartime construction would require rapid building, so they incorporated features that simplified manufacturing. The hull used straight sections wherever possible, because straight steel plates were easier to manufacture and install than complex curves. Internal compartmentation followed regular patterns that allowed repeated use of identical bulkhead designs. Electrical systems used standardized components that could be installed by workers with minimal training. This design philosophy sacrificed some theoretical optimization for practical manufacturability. A hull with more complex curves might have slightly better hydrodynamic efficiency, but the construction time, savings from simpler geometry, more than compensated for minor performance differences. An electrical system with custom-designed components for each application might have marginal weight savings, but standardized components meant replacement parts could be manufactured in quantity and installed by less specialized workers. Japanese carrier construction followed different principles. Each ship was treated as a unique creation, with components custom-designed and hand-fitted by skilled craftsmen. The approach produced ships of exceptional quality, where every joint was perfect and every system was optimized for its specific application. But it was slow. The Taiho, Japan's most advanced carrier, required 4 years from keel laying in July 1941 to commissioning in March 1944. The Shinano, converted from a Yamato-class battleship hull, required nearly 3 years from the decision to convert in July 1942 to commissioning in November 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. These timelines reflected Japanese industrial reality. Japanese shipyards lacked the heavy lifting equipment American yards possessed. Components were smaller because cranes could not lift prefabricated sections weighing hundreds of tons. Assembly proceeded sequentially because parallel manufacture of components required machine tools and factory space. Japan had committed to aircraft and other weapons production. Skilled workers were diverted to other projects because every industrial program competed for limited pools of trained personnel. The compound effect was that Japan could not replace carrier losses at rates approaching American construction. After Midway, Japanese carrier strength never recovered to pre-battle levels. The Taiho represented one new fleet carrier commissioned in 1944. The Shinano, commissioned in November 1944, but was sunk by American submarine Archerfish 10 days later while still conducting sea trials, never entering operational service. Several light carriers converted from cruiser or submarine tender hulls entered service, but these were stopgaps with limited aircraft capacity and reduced operational capability compared to purpose-built fleet carriers. American production in the same period was producing one Essex-class carrier every 6 to 8 weeks. By October 1944, when Lieutenant Commander Ohmae inspected the Franklin, the United States had more fleet carriers in service than Japan had commissioned during the entire war. The disparity was so extreme that Japanese naval strategy had to be completely revised around the assumption of permanent American carrier superiority. The Essex-class carriers entering service were not merely numerous, they were qualitatively superior in ways that Japanese intelligence only gradually understood. Each Essex-class carrier commissioned with multiple radar systems that provided comprehensive battlefield awareness impossible for Japanese carriers. Air search radar detected incoming aircraft at ranges exceeding 100 miles, allowing combat air patrol to be vectored for interceptions before enemy strikes reached launch range for their own attacks. Surface search radar tracked ships to the horizon. Height-finding radar determined altitude of detected aircraft. Fire control radar guided anti-aircraft batteries with accuracy that dramatically increased the lethality of defensive fire. These radar systems, integrated through combat information centers, specialized spaces where operators synthesized electronic data into comprehensive awareness that was distributed to all stations through interior communication systems. Fighter directors watched radar screens showing friendly and enemy formations. They vectored combat air patrol to intercept positions calculated to maximize defensive effectiveness. This capability meant Essex-class carriers operated with battlefield awareness that Japanese carriers could not approach. Japanese carriers late in the war carried radar systems, but the technology remained primitive compared to American equivalents. Japanese air search radar had shorter detection ranges and less discrimination capability. Integration with fighter direction remained manual and primitive. Japanese carriers lacked dedicated combat information centers with operators trained specifically in radar interpretation and fighter direction. The result was that American carriers detected threats earlier, coordinated defenses more effectively, and achieved defensive success rates that Japanese tactics could not overcome. The aircraft capacity of Essex-class carriers exceeded Japanese equivalents despite comparable displacement. The Essex-class hangar deck could accommodate over 100 aircraft with wings folded. Operational air groups typically numbered 80 to 90 aircraft depending on mission requirements and aircraft types embarked. This compared favorably to Shokaku and Zuikaku, which carried air groups of 72 to 84 aircraft. The Taiho, Japan's largest purpose-built carrier, excluding the Shinano conversion, carried approximately 75 aircraft. More important than raw numbers was sortie generation rate. Essex-class carriers could launch and recover aircraft faster than Japanese carriers due to superior elevator arrangements and flight deck organization. 4 elevators moved aircraft between hangar and flight deck more efficiently than the 2 or 3 elevators Japanese carriers employed. Deck-edge elevators meant aircraft movement did not interfere with flight operations. Crash barriers allowed simultaneous launch and recovery operations that Japanese carriers could not safely conduct. The practical implication was that Essex-class carriers generated more sorties per day than Japanese carriers of comparable size. In sustained operations, an Essex-class carrier could launch 3 or 4 major strikes daily, while maintaining standing combat air patrol and anti-submarine patrols. Japanese carriers, even when aircraft were available, struggled to match this operational tempo due to slower aircraft handling and less efficient flight deck operations. Damage control systems on Essex-class carriers incorporated lessons learned from earlier American carriers lost in combat. The Lexington had been lost at Coral Sea, in part due to inadequate aviation fuel system protection. Fuel vapors accumulated after bomb damage, then ignited in catastrophic explosions that doomed the ship despite successful initial damage control. The Yorktown had survived initial damage at Midway but was finished off by submarine torpedoes while under tow, demonstrating vulnerability to underwater damage. Essex-class carriers addressed these vulnerabilities with systematic engineering. Aviation fuel systems used inert gas to prevent vapor accumulation. Compartmentation was designed to isolate damaged areas while maintaining buoyancy and stability. Pumping systems could transfer fuel and water ballast to compensate for flooding. Electric power distribution was redundant with multiple generators and distribution paths that kept essential systems operating, even when damage severed primary circuits. The effectiveness of these systems would be proven in combat repeatedly. Franklin survived 2 bomb hits off Formosa in October 1944, the damage that had brought her into Ulithi for Lieutenant Commander Ohmae's inspection. Later, in March 1945, Franklin survived catastrophic bomb damage that killed over 800 crew and would have sunk any Japanese carrier outright. The ship was saved through superhuman damage control efforts made possible by systems designed to keep essential functions operating despite massive destruction. Anti-aircraft armament on Essex-class carriers provided defensive firepower that Japanese carriers could not approach. Initial armament included 12 5-inch 38-caliber dual-purpose guns in single mounts. These weapons could engage both surface and air targets out to ranges of 18,000 yards against surface targets and 37,000 feet altitude against aircraft. The mounts were fully enclosed, power-operated, and directed by Mark 37 fire control directors that integrated radar tracking with mechanical computation to achieve accuracy impossible with manually aimed weapons. Close-range defense employed 40 to 46 40mm Bofors guns in quadruple mounts and up to 52 20mm Oerlikon cannons. The Bofors represented Swedish design licensed for American production. The guns fired 2-pound shells at rates of 160 rounds per minute to effective ranges of 2,000 yards. Against aircraft diving on the carrier, Bofors, mounts provided devastating firepower that Japanese kamikaze pilots would learn to fear. The 20mm Oerlikon cannons supplemented the Bofors with rapid-fire last-ditch defense. Each cannon fired at 300 rounds per minute, though practical sustained rates were lower. The shells were small, but sufficient to damage or destroy aircraft at close range. Essex-class carriers bristled with these weapons, creating interlocking fields of fire that made close approach suicidal for enemy aircraft. Japanese carriers carried significantly lighter anti-aircraft armament. The Shokaku and Zuikaku initially carried 16 5-inch guns and 42 25mm machine guns. The 25mm weapons were inadequate in range, rate of fire, and explosive power. Japanese equivalents to the American Bofors 40mm guns did not exist in production quantities. Attempts to improve Japanese carrier anti-aircraft armament late in the war were hampered by industrial capacity already overwhelmed, producing aircraft and other weapons systems. The result was that Essex-class carriers could defend themselves against air attack far more effectively than Japanese carriers. This was not theoretical. The Battle of the Philippine Sea in June 1944 demonstrated the disparity with brutal clarity. Japanese strike aircraft attempting to attack American carriers were intercepted by radar-guided fighters, then had to penetrate anti-aircraft fire from carriers and escorts that destroyed formations before they reached attack positions. Of over 400 Japanese aircraft committed, fewer than 10% survived the day. American carriers suffered minimal damage. Lieutenant Commander Ohmae understood these technical details from intelligence reports and his own inspection of the Franklin, but the implications required weeks of analysis to fully comprehend. The Essex-class carriers were not simply superior ships, they represented an entirely different approach to naval aviation that Japanese doctrine could not counter with available resources. The strategic implications forced Japanese naval command to confront an uncomfortable reality that ideology had obscured for 3 years. American industrial capacity was not propaganda or exaggeration. It was material fact that rendered traditional calculations of naval balance obsolete. When Admiral Soemu Toyoda assumed command of the combined fleet in May 1944, he inherited a force that could no longer contest American carrier supremacy through conventional means. Japanese carrier strength in mid-1944 consisted of 5 fleet carriers and 4 light carriers. This represented the accumulated construction of Japan's entire wartime building program, plus survivors from the pre-war fleet. Against this, American forces could deploy over a dozen Essex-class carriers, plus light carriers and escort carriers in numbers that exceeded total Japanese carrier construction since the Washington Naval Treaty of 1922. The mathematical reality was inescapable. Even if Japanese carriers achieved favorable exchange ratios in combat, which combat results demonstrated they could not, attrition would favor the Americans because replacement rates were fundamentally asymmetric. Japan might sink one American carrier at the cost of two Japanese carriers, and within 3 months, America would have replaced its loss, while Japan's loss remained permanent. Admiral Toyoda's solution was the A-Go operation, later known as the Battle of the Philippine Sea. The plan concentrated every available Japanese carrier in one massive strike, intended to destroy American carrier forces through numerical superiority in aircraft and exploitation of land-based air power from Philippine airfields. If successful, the operation would buy time for Japan to rebuild carrier forces and perhaps negotiate a favorable peace before American industrial superiority became completely overwhelming. The operation failed catastrophically. On June 19, 1944, Japanese carrier aircraft launched in 4 massive strikes against American Task Force 58, commanded by Vice Admiral Mark Mitcher. The American force contained 15 carriers, including 7 Essex-class fleet carriers. The result was the Great Marianas Turkey Shoot, a one-sided slaughter where American pilots and anti-aircraft gunners destroyed over 300 Japanese aircraft while suffering fewer than 30 combat losses. The battle demonstrated that American carriers, with their integrated radar systems, superior damage control, and heavier anti-aircraft armament, had created defensive capabilities that conventional airstrikes could not penetrate. Japanese pilots, many of them hastily trained replacements for veterans lost in previous battles, faced coordinated defenses that destroyed formations before they reached attack positions. The few aircraft that penetrated to American carriers found anti-aircraft fire so intense that successful attacks were nearly impossible. Vice Admiral Jisaburo Ozawa, commanding the Japanese carrier force, lost 3 carriers on June 19th and 20th. The Taiho, Japan's newest and most advanced carrier, was sunk by submarine albacore. The Shokaku, veteran of Pearl Harbor and multiple battles, was sunk by submarine Kavala. The Hio was sunk by air attack. These losses were permanent. American production would replace American losses within months. Japanese losses were irreplaceable. The industrial systems that enabled American carrier production extended far beyond shipyards. The Essex-class program required coordination across thousands of suppliers, producing components that arrived at shipyards in precisely timed sequences that kept assembly proceeding without delays. Turbine manufacturers produced power plants to specifications that ensured interchangeability between ships. Armor. Plate mills rolled steel to thicknesses and treatments specified by naval architects. Electronics firms manufactured radar systems and fire control equipment that were installed as ships approached completion. This supply chain management represented organizational capability as important as engineering skill. American industry had developed during the 1930s through mass production of automobiles, appliances, and consumer goods. The techniques learned producing thousands of identical cars translated directly to producing dozens of identical warships. Component standardization, quality control, just-in-time delivery, all the practices that made consumer goods production efficient were applied to military production with systematic thoroughness. The contrast with Japanese industrial organization was stark. Japanese industry in 1941 was sophisticated and capable, producing excellent aircraft, warships, and weapons. But Japanese industry was organized around craft production rather than mass production. Each item was treated as unique, built by skilled workers who took pride in individual craftsmanship. This produced weapons of excellent quality, but in quantities inadequate for modern industrial warfare. Japanese aircraft production illustrated the difference. Japanese factories produced over 64,000 aircraft during the war, a substantial number representing enormous effort and sacrifice. American factories produced over 300,000 aircraft in the same period. The disparity was not explained by Japanese workers lacking skill or dedication. Japanese aircraft were often superior in individual performance characteristics to American equivalents. The Zero fighter remained competitive through 1943, despite being designed in the late 1930s. The difference was organizational. American aircraft factories employed assembly line techniques with workers performing specialized repetitive tasks. Components were manufactured to tolerances that allowed installation without hand-fitting. Sub-assemblies were built in separate facilities and delivered to final assembly plants, where complete aircraft emerged from production lines at rates measured in hours rather than days or weeks. Japanese aircraft production remained closer to craft manufacturing. Components required skilled workers to fit them properly. Assembly proceeded more slowly because each aircraft required individual attention to ensure proper function. Quality was often higher in individual units, but production rates could not match American output, regardless of how many hours Japanese workers labored. The compound effect across all military production meant that by mid-1944, American forces in every theater operated with material advantages that Japanese forces could not overcome through superior tactics or fighting spirit. Japanese soldiers, sailors, and airmen fought with courage that earned respect from their enemies, but courage could not compensate for systematic material inferiority. The Essex-class carrier program represented this American advantage in concentrated form. These were not simply more numerous carriers, but qualitatively superior platforms that integrated technological advances Japanese industry could not match, while simultaneously building them in quantities Japanese shipyards could not approach. The combination was decisive. By October 1944, when Lieutenant Commander Ohmae filed his report on the Franklin inspection, Japanese naval strategy had been reduced to desperate expedients. The Kamikaze Special Attack Corps represented acknowledgement that conventional tactics could no longer damage American carrier forces effectively. If trained pilots could not penetrate American defenses, perhaps suicide attacks concentrating explosive force at the moment of impact could achieve damage that traditional bombing and torpedo attacks could not. The Kamikaze campaign inflicted casualties and damaged ships, but it could not alter strategic outcomes. American carrier forces continued operations despite kamikaze attacks because damaged carriers were repaired or replaced faster than attacks could sink them. The Franklin survived massive kamikaze damage in March 1945 that killed over 800 crew. The ship was saved, repaired, and returned to service. Japanese carriers suffering comparable damage were total losses because Japanese damage control capabilities and repair facilities could not match American equivalents. The organizational genius that produced 17 Essex-class carriers in 28 months extended beyond the ships themselves to the entire support infrastructure that kept them operational. American naval bases across the Pacific received regular supply convoys delivering spare parts, ammunition, fuel, and provisions. Mobile repair ships and floating dry docks provided maintenance and battle damage repair, forward of major shipyards. Underway replenishment techniques allowed carrier task forces to remain at sea for weeks, while tankers and supply ships transferred fuel and stores without returning to port. Japanese logistics could not match this operational sustainability. Japanese carriers required return to major naval bases for replenishment and maintenance. Combat damage often required weeks or months in shipyard for repair because forward repair capabilities were limited. Supply lines across the Pacific became increasingly tenuous as American submarines destroyed merchant shipping faster than Japanese shipyards could replace losses. The strategic initiative shifted permanently to American forces because American carriers could sustain operations while Japanese carriers could not. American task forces ranged freely across the Pacific, striking targets at will because their logistics support allowed continuous operations. Japanese carriers were reduced to defensive positions because offensive operations required supply lines that American submarines and aircraft had severed. By April 1945, when the 17th and final Essex-class carrier commissioned, Japanese carrier forces had ceased to exist as effective fighting units. Surviving carriers lacked aircraft, trained pilots, or fuel for operations. The last major carrier operation, the suicide mission of battleship Yamato in April 1945, proceeded without carrier air cover because no effective Japanese carrier forces remained. The symbolic end came in July 1945, when American carrier aircraft struck the Japanese home islands in Operation Downfall preparation raids. These carriers operated with impunity off the Japanese coast. launching strikes against targets that had been considered invulnerable Fortress Japan just 4 years earlier. No Japanese carrier opposed them, because none remained capable of operations. Lieutenant Commander Ohmae survived the war and became one of the most important interpreters of Japanese naval history for Western audiences. His post-war writings emphasized that Japanese defeat in the carrier war was not due to tactical failures or lack of courage, but systematic industrial inferiority that made individual battles increasingly unwinnable as the war progressed. His analysis noted that Japanese naval aviation in December 1941 had been qualitatively superior to American equivalents in training, tactics, and equipment. But American industrial capacity and organizational efficiency transformed initial disadvantages into overwhelming superiority through systematic application of resources that Japanese industry could never match. The Essex-class program represented American naval power at its most effective. The ships themselves were excellent designs that incorporated lessons from earlier combat experience. But the program's true significance was demonstrating that American industry could produce complex capital, ships in quantities that rendered traditional naval calculations obsolete. Victory in carrier warfare belonged not to the Navy with the best individual ships or most skilled pilots, but to the Navy that could field overwhelming numbers of good enough ships with adequate pilots supported by logistics that sustained continuous operations. Japanese naval officers after the war studied the Essex-class program as a lesson in industrial warfare. The carriers demonstrated that modern war between industrial powers was won in factories and shipyards as much as on battlefields. The nation that could produce more ships, more aircraft, more weapons, and sustain higher losses while replacing them faster, possessed decisive advantages that tactical brilliance could not overcome. Admiral Toyoda, in post-war interrogation, acknowledged that Japanese strategy after Midway had been based on the hope that one decisive victory might shift the strategic balance sufficiently to enable negotiated peace. The term assumption was that American will to continue the war might collapse if losses were severe enough. This hope proved illusory because American industrial capacity meant that severe losses in one battle were replaced within months, while Japanese losses were permanent. The Essex-class carriers made American dominance visible in ways that previous weapons systems had not. A battleship represented years of construction and enormous resources, making each loss strategically significant. A carrier in traditional naval thinking represented comparable investment and vulnerability. The American ability to produce fleet carriers at intervals of 6 to 8 weeks overturned these traditional assumptions completely. The psychological impact on Japanese command was profound. Officers who had spent careers studying naval warfare found themselves confronting an enemy who had changed the fundamental rules through industrial power applied with systematic efficiency. Traditional measures of fleet, strength, counting hulls and comparing displacement tonnages, became meaningless when one side produced replacements faster than the other could inflict losses. The final irony completed itself in Tokyo Bay on September 2, 1945. The instrument of Japanese surrender was signed aboard USS Missouri, an Iowa-class battleship representing American industrial might. But surrounding the Missouri in Tokyo Bay were Essex-class carriers that had struck Japan repeatedly in the war's final months. These carriers, built in quantities Japanese planners had considered impossible, represented the industrial power that had made Japanese defeat inevitable once American production reached full capacity. Lieutenant Commander Ohmae stood on the deck of an American destroyer in Tokyo Bay that September morning and watched the surrender ceremony. 4 years after Pearl Harbor, the Navy he had served and analyzed throughout the war had been utterly destroyed. The carriers that had struck Pearl Harbor were gone. The pilots who had demonstrated Japanese superiority in the war's early months were dead or no longer capable of effective operations. The industrial base that might have sustained continued resistance had been destroyed by American bombers flying from carriers that Japanese forces could no longer challenge. The lesson was clear for anyone willing to see it. Modern industrial warfare rewarded not individual excellence in combat, but systematic excellence in production. The nation that could organize its industrial capacity to produce weapons in overwhelming quantities while maintaining quality adequate for combat effectiveness possessed advantages that tactical skill could not overcome. American victory in the Carrier War proved that industrial organization and production capacity were as decisive as any weapon carried into battle. The 17 Essex-class carriers, commissioned between December 1942 and April 1945, represented this principle in its purest form. Each carrier was a capable warship that incorporated technological and design advantages over Japanese equivalents, but the program's true achievement was demonstrating that complex capital ships could be produced at rates previously considered impossible through systematic application of industrial techniques adapted from peacetime. Manufacturing. Japanese industry had produced excellent weapons throughout the war. The Zero fighter remained competitive for years. Japanese torpedoes were superior to American equivalents for much of the conflict. Japanese naval architects designed carriers of exceptional quality. But Japanese industry could not produce excellent weapons in quantities sufficient to compete with American production of good enough weapons in overwhelming numbers. The mathematics of attrition warfare favored the side that could replace losses faster. American shipyards replaced lost carriers within months. Japanese shipyards required years to replace equivalent losses. American aircraft factories replaced destroyed planes within days or weeks. Japanese factories required months. This compound advantage meant that every exchange, even when tactically favorable to Japan, contributed to strategic American victory because replacement rates fundamentally favored American forces. By war's end, the disparity had become so extreme that comparison was almost meaningless. American carrier forces in August 1945 included dozens of fleet carriers, light carriers, and escort carriers. Japanese carrier forces consisted of a handful of vessels without trained air groups, fuel for operations, or capability for sustained combat. The Navy that had struck Pearl Harbor with such devastating effect had been systematically destroyed by an enemy whose industrial capacity had transformed initial tactical defeats into overwhelming strategic superiority. The officers who stood on Franklin's deck in October 1944 watching Lieutenant Commander Ohmae inspect their ship understood none of this. They saw a Japanese officer taking notes and asking technical questions through interpreters. They could not know that Ohmae was calculating the strategic implications of their ship's existence, recognizing that if America could build carriers at this pace, Japanese naval strategy had become futile. Ohmae's report to naval staff in Tokyo was received with skepticism by officers who found the conclusions too pessimistic. The idea that America possessed industrial capacity to build one fleet carrier every 6 to 8 weeks seemed beyond credibility. The numbers must be exaggerated, or American carriers must be inferior in quality to justify such rapid production. Both assumptions proved wrong. The Essex-class carriers were not inferior but superior in most meaningful measures to Japanese equivalents, and American production was not exaggerated, but if anything understated in intelligence estimates that failed to account for the full scale of American shipbuilding across all vessel classes simultaneously. The strategic lesson transcended World War II. The Essex-class program demonstrated that industrial capacity organized systematically could produce military power in quantities that tactical excellence could not overcome. This principle would shape Cold War military planning and remains relevant in understanding modern conflicts, where industrial base and production capacity determine sustainable force levels that ultimately decide strategic outcomes. For Japanese naval officers who survived the war, the Essex-class carriers represented the moment they understood their defeat was inevitable, not because Japanese sailors lacked courage or Japanese admirals lacked tactical skill, but because Japanese industry lacked the capacity to compete with American production sustained over years of total war. The 17 carriers launched in 28 months made visible what economic statistics had predicted, but military planners had refused to accept until confronted with evidence they could no longer deny. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.